Hello everybody, we're getting ready to do SAT Math Level 1, Section 6.3 Part 1, which is about circles. If you want your own PowerPoint, go at your own speed, contact me here at this email. If you want videos for the whole course, I can do that too. Email me. 6.3 Circles and their equations, Part 1. We got 30 points here for note-taking. You get note-taking guides as well. And then we got a skill sheet here of 66 points at the end of part 2. Overview. The SAT may also include questions that relate to basic relationships in the circle and in the XY coordinate plane. Circle terms. A radius is a situation here from the diameter out to the perimeter of the circle, or the center of the circle and a point on the circle. The plural of radius is radii. A chord of a circle is a segment whose endpoints are points on the circle. The longest chord of the circle is here the diameter, which passes through the circle. Angles and arcs. An arc is a curved section here. Here's a minor arc. Here is a semicircle arc here of a circle. A diameter divides circle into two equal arcs, each of which is called a semicircle, and an arc smaller than a semicircle is called a minor arc and is named by its endpoints. A major arc is an arc that is greater than a semicircle and an angle whose vertex is at the center and whose sides or radii are called a central angle, like this here. An inscribed angle is an angle whose vertex is on the circle and whose sides intercept an arc of the circle. The measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So, like for example, here to here, this angle measure here would be 1/2 of the angle measure there. If measure AC equals x, if the measure of angle AC equals x, then the measure of the inscribed angle ABC is 1/2 of this here. So in circle 0, AB equals 3 and CD equals 2. Which of the following statements must be true? 1, 2, and 3. It would be 1 and 2, 1 and 3, 1 only, 3 only. So since inscribed angles BAD and DCB intercept the same arc, BD, they are equal in measure. Also inscribed angles ABC and CBA intercept the same arc AC, so their measures are also equal. Since triangles AEB and DEC agree in two pairs of angles, they are similar. So the lengths of their corresponding sides have the same ratio. So we have the same ratio here since they are similar. These two triangles here are similar. And 2 times AB equals 3 times CE, which makes statement 3 true. There is no justification for concluding that line AB is parallel to CDs, or that angle ABC and DCB have equal measures, since they are not corresponding angles of a triangle. So it seems like D, 3 only, would be the correct solution here. 2 times AE equals 3 times CE. So 2 times AE would equal 3 times CE here. The correct choice would be D. So the circle formula is the distance around a circle is the circumference here. The circumference C of a circle depends on its diameter D. So circumference would equal pi D, which equals 2 pi r. The length of L of an arc of a circle is a fractional part of the circumference. So L would equal N over 360 times the circumference times 2 pi r. n over 360 times 2 pi r would equal this measurement here. N degrees over 360 times 2 pi r would equal the length of the arc. The area of a circle is the number of square units in the region it encloses. The area A of a circle depends on its radius. A sector of a circle is a region bounded by two radii and their intercepted arc here. The area A of a sector of a circle is a fractional part of the area of a circle. So we have AS equals n over 360 times pi r squared is what it will be. So this angle here would be n over 360 times pi r squared. So the length of an arc of AB of a circle O is 8 pi. So the length of arc here, AB, is 8 pi. What is the number of square units in the area of the shaded region? We have a 60-degree angle here. Find the radius of circle O. So the length of the radius would be 60 over 360 times 2 pi r would equal 8. So 120 over 360 times pi would equal 8. So 1/3 of r would equal 8. So r would equal 24 here in this situation. Find the area of a shaded region. So we have a shaded region here. So pi over 6 times 576, 60 over 360 times pi, and then we figured out our r here was 24 squared, which equals pi over 6 times 576. So this would be pi over 6 times 576 would be 24 squared would equal 96 pi for this area of this section. Tangents and radii. A radius drawn to a point of contact of a tangent is perpendicular to the tangent at that point. So we have a tangent here. This is the radius here that's drawn at a perpendicular angle to the tangent. Radius OP is perpendicular to the tangent T. So if here we have a sketch here of two radii here, and we've created a quadrilateral there. Tangents drawn to a circle from the same exterior. If the measure of angle P is x, then the measure of the central angle AOB, so AOB is 180 minus x. It'd be 180 minus x. If two tangents are drawn to a circle from the same exterior point P, the tangents have the same length, so PA would equal PB, PA would equal PB. Like there, you got your hash marks there. The opposite angles of a quadrilateral that's formed are supplementary. The segment drawn from point P to the center of the circle divides the quadrilateral into two congruent right triangles. These two right triangles are congruent and bisects AOB. AOB here. So these angles are congruent too. And APB, AOB, and APB, APB, and AOB, as well as arc AB. So we have a bunch of different bisections happening here at the back. Line segments PA and PB are tangent to a circle O at points A and B. The measure of APB is 60 degrees. APB is 60 degrees. If OP equals 14 over pi, if OP is 14 over pi, what is the length of the minor arc AB then? Angle AOB measures 180 minus 60 is 120. Since OP divides quadrilateral AOPB into two congruent right triangles at angle AOB, the side opposite the 30-degree angle in a right triangle is 1/2 the length of the hypotenuse, so OA equals 7 over pi, OA equals 7 over pi. Since the measure of the minor arc is 120, the length of AB is 120 over 360 times 2 pi times 7 over pi. So the length would be 1/3 times 14, which would equal 14 over 3. So then gradient of that would be 14 fraction bar 3, 14 over 3. And that was 6.3 part 1. If you want the PowerPoint, I can get that for you. If you want worksheets, if you want online tutoring, contact me. Thank you.